Hi everybody and welcome to our joint webinar on the topic how to build smart cities. No artificial intelligence without a proper information architecture. So bear in mind early morning birds or afternoon dwellers. Our ambition today is to guide you through the necessary steps to building a sustainable smart city and highlight some of the opportunities and challenges you will meet along the way. We'll be talking about artificial intelligence, semantics, information architecture, and mention about cases, practices, and guidelines, as well as tools in the process. This joint webinar is brought to you in between Findwise and the Semantic Web Company. Some housekeeping rules. This webinar is in broadcast mode and all participants are muted. Please put your questions in the GoToWebinar panel and we'll answer as many as we can in the Q&A session. This broadcast is being recorded. Replay information will be sent out to all registrants following the broadcast. So, who's speaking today? Well, first, it's me, Fredrik Landqvist. I work as a principal information strategist and a researcher at Findwise and also educator at the Gothenburg University. I've been an information professional for the last 29 years, and for 25 years, I've specialized in advanced information management, search, semantics, and analytic tools, and blended all tools and vendors known to man. My research mainly focuses on knowledge management, knowledge engineering, communities, and learning networks and innovation. Second to me is my friend Martin Kaltenbach, who is the CFO for the Semantic Web Company and who will introduce to you the semantic layer and the semantic tooling we can foresee to be used. And then my friend Sebastian Gabler, who is sitting next to me here today in sunny Gothenburg. He works as a sales engineer at the Semantic Web Company, and he will introduce some recent fascinating, intriguing cases. The agenda for today, I will start with the introduction to the theme, then Martin will continue with the semantic information platform. Sebastian and me will show you some cases and also some tools. We will end up with a takeaway of some thoughts around the table and then finish off with some Q&A for all you to participate. So, the cognitive revolution. Well, currently, in all aspects of life, we are entering an age of highly connected and data-driven change. When talking about smart, we often relate to cognitive skills, conscience, and tooling capacity and sapience, or wisdom, if you will. Artificial intelligence is emerging in everyday uses and is becoming a commodity, and that at best interplay and guide us in everyday life. Contemporary technologies are mainly narrow AI, but in the horizon we envision artificial general intelligence. So the pathway to this future needs sustainable principles and guidelines. Sapiens. Well, we as humans raise our relatives in the Homo lineage with outstanding capacity for communication, thinking, and used shared narratives to build imagined realities. As hunters and collectors, we domesticated fire, and all of a sudden we could cook food. Brilliant for our nutrition. We also developed linguistic skills that gave leverage in our cognitive revolution. The collective imagination is what nurtured organizations, shared belief systems as religion, basically in short, cultures and our behavioral patterns. An imagined large social habitat finally became a city, or a smart city if you will. So the transition from foraging to agriculture and further domestication of animals and crops proved sapiens to be extremely good at creating such imagined entities as a city. But as the biblical script tells us about the Tower of Babel, with large human actor networks, there tends to be a problem with the information that gets lost in translation, and that leads to linguistic uncertainty. Modern urban cities rely on the very same social construct and organizing principles as the ancient cities, except the high density of connected reality with things and people. A leap in the cognitive skills was the advent of written annotation, codification of knowledge and data, bypassing the oral tradition with new means to store, share, and externalize content from the minds of the city inhabitants. The first clay tablets, cuneiform, as in this picture, were Parser's script, had two distinct categories. The first one being facts or data, a system of shaped tokens used for accounting. The second one was the concepts or the topics. Basically, a spreadsheet or a tabular schema or a database, if you will, with label columns and data points and values. Later, full scripts emerged where oral storytelling became equivalent to today's documents. Linking the concepts and shared vocabularies with narratives were already at this early stage a problem, and this need to add semantic meaning to data still prevails in moving into artificial intelligence. Meaning is subjective. It's highly demographic, it's social, and it's political, and it's very complex. Bear in mind, I've been married to the same wife for 20 years. We speak the same language, and we share the same habitat and the social band called family, and we share the same values, but still, we misunderstand each other on an everyday basis. Due to the simple fact we have different subjective ideas of the shared topics we are talking about. Sometimes, and most of the time, we actually share the same ideas and going forward, but we also sometimes argue and get into discussions. So with this fascinating organizing capacity, as humans are extremely well suited for sharing means to organize things, the social fiction of a shared narrative. When the clay tablets and data stores grew, a completely new practice emerged, namely librarians or professionals who constitute organizing principles to the collections, to be able to archive, catalog, and retrieve. Simply put, ancient Googlers. Another angle to organizing mass cooperation and collaboration is by using standardization. This has always been the means to build empires through either mitigation, conversation, or rather brute force. A shared imaged order as the monetary system or the layers of standards underpinning the structure of internet will by nature ease cooperative work, as long as all actors act in coherence with that specified order. But there are challenges, as in this picture, with the first picture states death by laundry. We've all been there. Lots of data from different stores, and it doesn't render itself in a good manner. So if you put the wrong things into your laundrette machine, it will not end up in a good way if you don't read the metadata or the resource description. Similar to everyday purposes for anything we do. So the problem is that each expected outcome in the work of managing data will be enveloped into a specific organizing system. An organizing system is a collection as piles of clay tablets of resources, the clay tablet, arranged to support some set of interactions, similar as your collections of sites, documents, and what have you in databases or SharePoint sites. With heterogeneous organizing system, it becomes a problem because the intentional arrangement of one organizing system might not support the required interaction in another context. Anybody who's been working with data management, or bear with me, master data or business intelligence or data warehouses have raised this question because the organizing principle from the starting or the source of origin might not be well suited for analytics because they didn't think about that organizing principle in the first place. So, as with today's emerging smart cities comprising of sensor data, social feeds, and legacy systems in organizations and public authorities that do not interoperate, with a chance of model misconceptions that severely impedes eloquent data. Information architecture is this design an abstract and effective organization of information, and then exposing that organization to facilitate navigation and use of the content or data. There are basically 5 ways to organize information, either by location, by time, by category, hierarchy, or alphabetically. So how do we mass the data in the abundant masses of bits and bytes without falling into a digital landfill? With the Neolithic revolution emerged bureaucracies and accounting, as mentioned before, with the Sumerians, and the king wanted to get taxes from the peasants, and by that enforced clay tablets to keep track of monetary resources. The hunters and gatherers, they didn't bother with math. If they, run into a tree with apples, they didn't start counting them to see how many there were to divide them in between the friends in their band. No, they just ate them. So the mathematical notation and numeral system and the symbols are actually the only written language that is truly lingua franca. The scientific revolution created the notion of challenge stated facts and investigate new ideas, using data aggregation from the field to develop, explore, trial, and validate mathematical theorems. As with the statistician and Presbyterian minister and philosopher Thomas Bayes, who tinkered with probability and statistical science, leading to the Bayes theorem after his death. The latter underpins many present-day AI algorithms. Such mathematical giants have created the proven theories that the computing technology rely on. Their methods of validating models with quality data is still the only way forward. You can't start using AI without having a sound and working model, and you have to validate that with proper data. So, what is the bright side of the road? Well, narrow AI, as mentioned before, is already a commodity, and we see strong currents of emerging standards that will interconnect the future smart cities step by step. We should not try to boil the ocean. So let's lean on the upside to the change, building a web of meaning, because if we lack meaning, we will never be having useful uses of the smartness in any set of tooling. Also, we should consider the benevolent and sustainable AI supporting emerging smart cities, because we don't want to have surveillance or bad behavior using the data captured in our everyday lives. And that all boils down to trust and belonging. A participatory design with, sound and working AI principles should be the way forward. So, how do we bring together order in terms of information architecture with meaning, the semantics, combined with the cognitive layers artificial intelligence, within the smart city theme. And here I hand over to my friend Martin. So please go ahead, Martin, and show us the cases.
Into our topic. So no AI without EA. Just a second. I take my screen and hopefully you see now my screen.
Yes.
Okay. Thank you very much for this wonderful introduction into the topic that gave us a lot of information about the challenges we have in our information and data management and structuring. And I will go into detail a little bit. My name is Martin Kaltenberg. I'm CFO and managing partner of the Semantic Web Company. So I'm calling in here from Vienna in Austria. To the friends sitting in Gothenburg in Sweden, that is Frederick and Sebastian. I will give you a short insight into our tool, that is Pool Party Semantic Suite, that can help to solve these problems and challenges that we have learned from Frederick. So taking one of your slides and taking it further, you showed something. It was a quick overgoing about the evolution of human being. We have adapted this for the evolution of the internet as well as for data and information management. So if you take a look at the left-hand side, you see that we have started around 25 years ago with the documents on the web. And I guess everybody in an organization, in an enterprise, and in a city or a municipality knows about this. We have bunches of documents and we have linked these documents all together. So we have the web or a graph, a network of documents that is called hypertext. But these days we see that more and more data is on the web, and more data is in organizations, and data is in cities. Nevertheless, they're smart or not yet smart. So we see data. This is unstructured data. This is semi-structured data. This is structured data, like data points coming from sensors. And we want to link all these data and information together so we can gain out some knowledge. So on the right hand side, you see we are going into a direction of a web of data, aka hyperdata, we call it these days. So coming from all these network of documents, we're going into a network of data. How are we going to do this? Here we have a core principle that we have here in this 4-layered architecture of content and data. So you see usually what you are absolutely familiar with on the bottom. Different or data comes in from different sources. Heterogeneous data means in different formats like XML, like documents, like data points from sensors. So we call it here the content or data layer, all the repositories that we have, and we want to integrate them and harmonize them. So what we also have in place most of the time is a metadata layer, means a layer that is describing the data, explaining what is in the data repositories and in the data sets that we have. And until now, we also have this navigation logic and all these applications on top. But what is missing, and this is what we're adding now in our approach, is the semantic layer. The semantic layer in the form of knowledge graphs, ontologies, or taxonomies, controlled vocabularies, as you can also hear very often, is a layer that is connecting the metadata and the data so that at the end you have very powerful integrated data that you can make use with for semantic search, for recommender engines, for analytics, for smart applications. So if we go again down to the bottom, we see always that in different departments in a city or different areas that Frederick described before, there are different types and kinds of people sitting. Everybody has his own mindset, and these people are modeling their data and their databases. So what is the result? We have different models in place. And then we have also different terminologies in place, because 3D models or health or I don't know, let's say traffic systems, people are using different terminologies in all these different areas of the city, or electricity and so on. And the third one is very often these days in Europe, we also have a language problem or a language barrier. We have 24 different languages in the European Union. So different data, different mindsets, different terminologies and several languages in place. And this can be solved very well with a semantic layer that is mapping all these things together and thereby enabling very powerful applications on top of it, and thereby enabling a city really being smart. So not only using different smart technologies, but having the smartness in a knowledge graph that is connecting all these smart applications together. Another core principle in the semantic web and using linked data and our approach, semantic artificial intelligence, is we are always using things. So we're speaking about things and not strings. Here you have an example that is very famous in the meantime. You know, if you take a look for Jaguar, then you see there are different things of a Jaguar that are using the same string. So it can be a car, it can be a cat, it even can be a tank, or it can be an operating system. So usually we as human beings, we know how to read the context and understand that we are speaking about the animal because we're speaking about cats and jaguars and panteras and so on and so forth. But the machine is not that smart. So we have to teach this machine that the machine understands what a thing is, what the Jaguar as an animal is, and what the Jaguar as a car is. And this is a very important basic principle of semantic web and semantic technologies, to teach the machine and the engine about these core principles. So how we are doing this with Poolparty Semantic Suite in regards to technical components, we start on the left-hand side. Poolparty has a very powerful editor where you can model your vocabularies, your knowledge models, no matter if it's about geography, it's about health, it's about electricity and so on, or about traffic. You can model or you can import these different models, vocabularies, or taxonomies, even ontologies, if you want to model complex systems or structures. And then this is used in the form of an entity extractor and classifier. So we are using the models that can be interlinked and mapped to each other. So this helps also to map, for example, something from health to a model that comes from energy. And thereby we are teaching the engine then, when it comes to data integration from unstructured, semi-structured and structured data, using the model in the middle that we have built, so that we can integrate all these heterogeneous data from different sources. In the big data terminology, we speak about variety from all these sources and all these data formats, to then have an RDF graph database. So we store it as a graph, as a knowledge graph, and can then have very powerful applications on top of it. So we're taking the different data sets in different formats from different sources, we map them and their metadata models to a unique model, or we link the different models together, and then we can have powerful data integration to have uniform data in place that we can compare, analyze, and work with. Here comes semantic AI, artificial intelligence, also in place. So what we are doing in Poolparty is we are taking the best of both worlds. So on the one hand side, we have semantic technologies in the form of a knowledge graph of models, this semantic layer that you see here in the middle. And on the other hand, we take machine learning and other cognitive computing approaches. Here machine learning is named as an example, and we mix this together, or we make use in both directions. What does that mean? We use this model, the knowledge graph, to enable the machine learning algorithms to do more precise analytics. So really taking into account the relations in the model and everything that we have in this model. And the other way around, we are using machine learning techniques, for example, to improve continuously our model, our knowledge graph, our semantic layer, because the algorithms are processing more and more data, and they're feeding back into our knowledge graph, into our semantic layer, everything that is learned over time. So with a lot of data, it can be very powerful, and the graph is also expanded continuously. So this is what we call semantic AI, beside other aspects that you find in our semantic AI paper that is also in the further reading sections, and that will provide it with our slides later on. So here is what Poolparty is also called. It's one of the most complete semantic middleware solutions on the global market. So it's very important. We are fully standards compliant in direction of World Wide Web Consortium standards, W3C. And here we are making use from the very beginning of the full semantic web layer cake that is in place, all the W3C recommended recommendations. It's a middleware. What does it mean? That you can easily integrate it into your existing technology stack. You don't have to replace anything. You're just adding the middleware into your technology stack, into your infrastructure, and you're connecting it because we are providing very, very rich APIs in place, so that people get quickly also into the loop to work with Poolparty. We have invested a lot in user friendliness, and we have an e-learning program. I will tell you more about free possibilities here. We are using leading technologies. We're also having around 20% of the company here is doing research and innovation projects. That means that our roadmap for the next 3 years is financed and already in plan in regards to research and innovation. And we have a very modular architecture that you can take a deeper look on poolparty.biz. A short referral for further readings, you can just go to our Poolparty Biz vocabulary hub, because Frederick mentioned it's very important to use and reuse existing standards and vocabularies. And here in different areas, you find freely available a nice set of standards and vocabulary to reuse, for example, the ISA 2 program vocabularies or other ones in different domains. How to start if you want, you're interested and you want to go ahead with your own data, with your own use case with us. So Findwise together with Semantic Web Company can set up a Semantic Web starter kit together with you. This is a little proof of concept, a POC, where we identify an important use case. We implement that use case together. The software is included, for example, a semantic search use case. And then you have your prototype that you can see with your own data in place. And we also work together on a strategy white paper, what happens after a proof of concept. So how you can make use of semantic AI inside your organizations, not only for one use case, but for several use cases. And finally, I would like to guide you to 2 interesting areas. The one is Poolparty has a free demo account system. So just go to our website. There is a big button on the top right corner saying try it or try now. And then you can go for a 30-day demo account for free. And the second thing mentioned before is we have our Poolparty Academy, and there is the first module open. You just have to register and then you can freely access it. It's about semantic technology training with videos and little tests so that you can find more or learn more into this direction. That's all from my side. Before I hand over, there's only one final remark. We have the 14th edition of Semantics Conference this year. This year, we're coming back to Austria. It's in Vienna from the 10th to 13th of September. The URL is semantics.cc, also in the reading section. And there you also find we have a data science track and an AI track and a lot of semantics there. Get in touch with us, come to us, and we're happy to discuss there, but also via other areas. So that's all from my side for the moment. So I think I hand over, not sure, or you give the screen to Sebastian, I hope.
I will hand over the screen and make Sebastian presenter. Thank you very much. And, let's see. So now Sebastian will be the presenter, and hopefully everything works out smoothly in the transition in between.
Oh, you should be able to see my screen. My name is Sebastian. I'm working with Martin as a consultant together at Semantic Web Company, and I will introduce you to a use case about trusted health information for Australia. Basically, Health Direct is a part of the public health services for Australia. They have established a digital platform which is drawing upon Poolparty Semantic Suite in the year 2013. So we are celebrating the 5th anniversary of this. And this is an example that is relevant because it is an infrastructure, it's an architecture, which is providing something different than Dr. Facebook. So it's really providing the trusted information for the public audience and also for the practitioners and other workers in the health system. The idea of Health Direct was that they wanted to have something that is based on the W3C standards and something that is reusing publicly available vocabularies, which are industry standards for health, such as the medical subject headings, the IDC-10 classification for diseases, and the drug bank for medicines. And the scope is to basically interlink these different knowledge domains to each other and provide rich services such as the Australian Health Thesaurus, which we will see later, a symptom checker, which is a kind of self-service platform for the public audience, and a semantic search for their website, which will retrieve information based on entities instead based on things. So the mission statement of Health Direct is that Australians really have the appropriate care and information, and they have to have it when they need it and where they need it. As you know, it's they have a specific issue that Australia has a very large area and not so many people. And digital technology can really help to tackle this challenge. So this is the core of the business case here. The technical platform is basically picking up what Martin was already aiming at. Pool Party is just connected to the enterprise service bus at the Health Direct technical infrastructure, and it's a non-intrusive approach of providing the semantic services for the applications on top, and is nicely integrating with a digital asset management system, with a content management service, and with an enterprise search platform. Why was Pool Party Thesaurus server used? It's basically used as a modeling platform, as Martin managed, and it's used for managing and publishing the linked data that Health Direct has modeled within their Australian Health Thesaurus, and it's providing it to the application, to the services for the public, and it's also providing semantic information to 120 unstructured information sources, so documents which are about health information, and those are annotated with the relevant entities and with the relevant knowledge about them, so that people can find them on the Health Direct website. So as you see here is a small screenshot of the modeling of the Australian Health Thesaurus from the backend side. So you see here that's it's integrating the different sources I've mentioned. Actually, I forgot the DSMV. It's also integrating local thesauri that have been previously used in the connected systems. So there is a centralized approach for modeling the knowledge, which is really important for such an information architecture. And it's really heavily in use, or there are more than 10,000 changes since the system was brought into place. So data governance is a very important aspect on the whole matter. So one of the first steps, of course, is the conversion of the XML-based thesauri of the local thesaurus systems. And what you can see here is one of the main scopes. It's the handling of language. So the common audience would say, oh, I have a tummy ache. But the medical term, of course, is abdominal pain. So by handling these synonyms, the knowledge graph can handle different levels of language. And a user searching for tummy ache will still be presented information about the information which is related to the right medical term. So this is what I was actually starting to mention. So the labels, the literal information, are used for type ahead. They are used for synonym checking, and the context information, the resources within the thesaurus, And the hierarchy and non-hierarchical relations here will provide related information and thus provide facets for the search, dynamic facets, and also search expansion, so avoiding empty search results, vastly improving the user experience. The content publication process is pretty much straightforward. So Pool Party Extractor is automatically annotating all the different information sources. So it could be local content, which is in the CMS, but it also could be public content that is harvested from other websites. And it is quality controlled, published into the direct platform. So let's break out of the presentation mode and let's look into 3 of the main services here. So the first thing I was talking about is actually the type ahead. So as you see here, the markup terms are actually the entities from the thesaurus. So I could start, for example, the symptom checker on depression. That's another service, self-service. I could do a refine of the search. So I can narrow down on these life stages, which are also facets from the thesaurus. I could find geographical information. So I could find a pharmacy which is related to the topic. So you see, it is using my own location if I provide it for it. And it is providing textual resources, but not by the textual resource, but by the topic I was actually looking for. So let's start the symptom checker for a moment. What is very important, of course, is in health cases that there is a very low threshold of providing direct help. So there is a helpline, of course, so you can talk to real people in case you need it. And now I could, for example, go through this chain here. So I can provide a bit of context information. I would say 10 months. So I have a male child and I say I'm in Sydney. It will look up my postal code. And this is guiding me through the steps. And I could say, okay, I'm feeling rather, or the child is rather feeling warm. And then I say, okay, it's not such a severe case, of course. Not everything is dramatic. And it's not so bad. So no vomiting involved. No further symptoms. No further symptoms here as well. But the child has high temperature. And so it will send me to the right general practitioner. And I can locate the nearest health service to the place, to the postal code I have provided. And of course, they are in a different time zone, so most of the doctors are closed. But when I would have provided correct location information, I would have, I think, very good results. On the other hand, Pool Party is used to serve directly the Australian health thesaurus, So it is publishing linked data that can be used by other organizations. So Australia has a already very high infrastructure on linked data for the National Archive. Health services, education services are using a semantic web information for providing smart applications. And here I can actually get this data either in human readable form, but also in the machine readable form. So this was not working. And so actually the RDF data will be provided to me. And so a machine can actually get all the content information and the context information. You see also here the alignment to the public available vocabularies. And you see the resources that I can actually query next to get more information for my own smart application. So this is a very important aspect of using linked data for driving my own smart application. So this is actually already the end of this use case presentation, and I would like to hand over to Frederick.
Thank you, Sebastian, for that nice case from Down Under. And now we will move into my hometown, being Gothenburg City, or the municipality of Gothenburg, with a recent case on how we envision the journey to a smart city and leveraging the city as a platform. Which are the models, the challenges, the effects, and possibly also what kind of solutions we foresee going forward. I would like to just give you some basic facts about Gothenburg. Well, it's a city that has been founded 1621. Its inhabitants is about approximately 573,000, and in the larger region of Gothenburg, we are approximately almost 1 million people, and it's the second city of Sweden. Or if you ask me, it's the best city in Sweden. Do not compare it with Stockholm. Gothenburg is the place to go. It's also divided into 10 city parts or larger neighborhoods. So it could actually be seen as a city of cities. The municipality is running 20 different administrative organizational units, taking care of education, healthcare, and parks and traffic and what have you. The city also owns 60 companies, like the energy company, the parking company, and some others. It employs 54,000 employees, whereof 37,000 of them actually work within healthcare, social welfare, and education in the city parts. Also, the city has almost 350 and counting or more legacy system, information system, and a multitude of platforms, and a very heterogeneous information environment, serving both employees, partners, citizen visitors. So there are quite a few known challenges for Gothenburg, similar to any urban city of today's present day. One of them is, well, we have a growing population of older people that expect efficient service provisioning. Also, one interest is that, well, the works done by a municipality is based on tax money. So it's also good to know how much money goes to what bits and parts of the system. From the Gothenburg region, it's 85% goes to education and social welfare and healthcare for the elderly people, and the rest is mixed up with traffic and whatever it could be. Gothenburg decided, as many other urban areas and cities, that it would move on to the digitalization pathway as digital first, with open, efficient, and easy to use services in all domains. And the main categories in that from the city is obviously running education, healthcare and social services, cultural democracy, participation, business, work, city planning, environment, and more. To underpin this, there are also a set of key focus areas to become truly digital. And one of those are information architecture, with shared vocabularies and models. Also infrastructure for security and safety, and governance and management and leadership to be compliant with laws and regulations. So how do we create sustainable data management? With a very heterogeneous information environment, the ambition is to set a data governance principle with sound roles and responsibilities all through the content continuum. In Swedish, grundvattnet equals to groundwater, hence shed in, shed out prevails, and we do not want polluted drinking water, and the same goes for the different categories of data. So how do we build a city information model? Well, all complex adaptive systems revolve around a set of autonomous agents. In example, cells in human body or citizen in an urban city. The emergent behavior in a complex adaptive system is governed by self-organizing principle. A city information architecture is by nature resilient. It is by nature, an complex system, and hence the design has to be resilient and coherent. The model has to be, flexible enough and fluid enough to work in a continuously moving and changing environment, but still also be structured in a way that it actually holds. The models have been set into a set of main categories. The first, most obvious one is, well, it's a spatial area. The municipality and the city is a spatial area. Within that, we have the urban environment, which comprises of all the things that make up an urban area, as houses, neighborhoods, streets, parks, and more. And each category of these things have different kinds of organizing systems to have a sound record keeping of the available resources. These models might be, an example, building information models for the houses, or geographical information systems with maps and terrains described in resource descriptions. Secondly, that we have the movable objects, which is basically all the things that have sensor capacities as traffic, cars, and more. In short, the dynamic environment within the city. Thirdly, we have the human actor networks, which is all the organizations and public service authorities and networks of individuals as citizens, visitors, and more, using a mix of services with internal legacy systems as well as social platforms for data. Lastly, we have the virtual urban system, which is an augmented reality or a virtual environment used in visual engagement and development of the city. Leaning on models. Well, the ambition have been to use different shared imaged narratives to describe the city, hence model-driven. The city also realized that there are many emerging standards to cover all the different categories. So we do not want to invent the wheel, but rather lean upon imaged order, known standards. So if you move into the urban environment, well, real-life things and experiences with the digital shadow resources. All urban areas have a multitude of things that step by step become digitally enhanced. These structures will be by nature organized in different organizing systems as BIM and GIS. The key thing when modeling the environment is to expect the life cycle perspective both to data and things. The details in the BIM might not be eloquent data to facility management or city planning, but useful tidbits combined with the other structures. Movable objects. Well, a dynamic data environment with all kinds of sensors and movable objects as cars and the like. In most scenarios with smart city, the vision encompasses Internet of Things, surveillance, monitoring of all interacting actors, to get more safe and secure environment with autonomous agents helping us through the life and business events. Emerging IoT standards as FireWire will be crucial to prevent lock-in mechanisms from different vendors and agents, reaching for interoperability. The movable objects category is situated with many different platform owners and corporations. The human actor network. Well, people act in networks or imagined entities as corporations and public agencies. To build a web of meaning where these perspectives are intertwined into intersubjective levels is possibly the toughest challenge of them all. Mass cooperation and collaboration with active networks of both citizens, pupils, politicians, patients, visitors, and business partners will by nature have very different organizing systems. And having that in mind, the shared narratives with life and business events trigger the services using the city as a platform would be a possible outcome. To be able to visually describe the city, there are many different means to augment the urban environment and illustrated virtual futures of the city. The complexity in building a city in a sustainable way do need a participatory design. 3D models on platforms used by digital natives to engage in their future use with Gothenburg, as in this case, Gothenburg virtually in Minecraft, where the kids can play around and build their own neighborhoods or tear down buildings they don't like in Minecraft. All building blocks are actually derived from the BIM models and more. Also, as mentioned before, participation for the city models. A very practical use of augmented and virtual reality is to let the citizen and visitors add their own narratives to physical spaces. A shared fiction, as well as taking us back to the past experiences of the city with model of the Renaissance 17th century harbor city. Standards. Yeah, I like them. By using standards in all main categories and build meaningful domain models, one open up for the information exchange between all levels. In short, we are reaching for interoperability. In this specific pilot and the works we are doing now, we are using open standards like before mentioned Simple Knowledge Organizing Systems, or SKOS by W3C. Also rendered itself into RDF, the Resource Description Framework. And all the models like the ISA2 and terminologies like Eurovoc, Integrated Public Service vocabulary from the UK, and more to semantically enhance the data. Second to that, as I mentioned, we also use RDF schemes and ontologies to describe the relationship between the different entities to reach for a further improved semantic enhancement. So here's the beautiful model. Not rather beautiful, but it's an information model for anybody who's been working with domain models or UML models from the Interoperability for Public Administration, or in short, ISA2. As all models and standards, it has its drawbacks, it has its capacities and good things. So what we have done basically is look at the model, look at the opportunities, the data that we actually do have in place, and start mapping those conceptual means to bring meaning and order to the things. That said, it's not saying that this is the perfect one to rule them all model, because there is no one to rule them all model, but the good enough model, that is a way forward. So in this case, we are looking at the information flow, or the value chain, if you will, of information from its origin to where it's used or repurposed or reused in different systems, being actors, being systems, or people. In many ways, many of the key properties and entities we are looking at, like people, organizations, places, and services, they are actually originated or described in record-keeping systems outside the city or within national agencies within the government, who has the core responsibility to keep track of those things. As the people registry we have in Sweden with a personal number, with attributes and properties defining who I am as an individual and where I live and so forth, similar to the organizational registry to keeping track of all the different corporations and public authorities and their whereabouts, and similar to the mapping registry, which is an agency that's been doing train mapping for centuries. These resources are and should be interacting with internal resources. So the internal resources might comprise of the identity and access management systems that the municipality run, the HR system keeping track of members of staff with the roles and responsibilities assigned to that. We also have the tracking of the economy and the finance, and we have the geographical information systems with maps, lots of maps and lots of different ways. A city is a spatial area inhabited by people and things. To combine that, we also add the terminologies as before mentioned. The terminologies are used as value sets to categorize and structure and annotate what might not be already existing in the internal systems, because as mentioned before, the organization principles for one instance might not be working for another one. So we try to use the terminologies and standards to improve or semantically enhance data to become even better in the flow of events. So here are some examples of shared terminologies. We might have reference data, we might have control vocabularies or simple lists or CSV files that we have downloaded, which are reference points to categorization within the domain of the specific area. We might have open standards, taxonomies, or very valid thesauries and well-developed vocabularies. It could be code systems used across for the healthcare provisioning or for the geographical spatial definition of things. All of these things we all store as simple knowledge organizing system or SKOS terminologies. Second to that, we model the master data or the data using the core vocabularies. So we have the persons, which is the individuals, entities being organizations or organizational units. We have places, which addresses or geographical coordinates, or location or spatial areas, and lastly but not least, services, which could either be internal or external. So in this case, I've just rendered a fake example of a person who has several different facets to life. He might be a member of staff, citizen, a pupil at the local school, and even a politician. And in his employment, or he might have multiple employments, he plays different roles and responsibilities assigned to that, depending on his whereabouts. This is where the graph comes into play, because you are able to connect all these links with terminologies and a person and relate that to his whereabouts, where he's working, and where that organizational piece is situated. Same goes for the organization. So we define an organization as something that is registered by the National Authority of Registering Organizations, but each organization has its own inbuilt organizational hierarchy. the organizational structure. So we combine the record keeping of the top level organizational properties with the classification schemes that is going across from different standards and link those things together, as with the organizational units. And the thing is, with the organizational units, you might think that it's a very easy target, saying, well, we know the structure of our organization. Well, yes and no, because the different practices within the municipality have different ways of organizing the organizational structure. If you are an accountant or a guy who works with the finance and the economy, you are mainly focused on the cost center structure. Whereas if you work in HR, you would like to, put people into boxes with a manager and build a hierarchy in that, scenery. Or if you are facing with external facing services, you would likely not to present to the end user of any e-service or public web page with the cost center as a kind of a structural means for organizing, but rather the name of the school or the name of the place or the name of the entity. All of these things makes a graph with connecting organizational units that by definition share the same structural elements but have different origin. Same goes with places and areas. A organizational unit might be having several different addresses, and those addresses are located in different spatial geographical locations like city parts, areas, neighborhoods, and what have you. And all of these things are interconnected using the GIS system to get the unique spatial services and unique URIs to define the spatial area where a thing, a service, or a organizational unit is positioned. And the same goes here with the services. We use the core service vocabulary, core public service vocabulary, to define the metadata structure for the service, and by then we are able to instantiate that in different workflow system internally, and also realize that services is part of, which means a package of services into offer and service categories into the different classification schemes. So we envision the opportunity to have a national service catalog for the municipalities that goes across to 290 different municipalities in Sweden. Ending off with this. The ambition is to get the utility of smart data. Smart data doesn't come by itself. It comes through sound information architecture and organizing principles. We know that the information and data landscape will be comprised by files, records, different social conversations, and sensor data or what have you. But if we don't have semantically enabled tools to bring order and meaning to those things, it will be very, very difficult. The way we have looked at this as well is to provide it with a synchronous, or using the enterprise service bus or the integration engine to send information parcels, if you will, to the next system accordingly to the record keeping of the standard. We also look at using the synchronous or RESTful API or SPARQL API to query the graph. But the main thing is it should be independent on this different supporting system, as long as we rely on a coherent use of the standards. And that makes it interoperable, and information should be reusable in any future space. So that in mind, I'll just leave you with a graph, because we've been talking about graphs all day. So here is the graph. The graph of Gothenburg in brief. So thank you very much, and now I hand over to Sebastian to take away some thoughts for the future. Thank you very much. Sorry, Sebastian.
Sec. So as we have learned, there is no smart city without a appropriate information architecture. The tools are there, the technologies are there. The semantic web has made a long way, and it's has come to a productive state. So just a couple of closing thoughts. An information architecture is a commodity that is actually valuable for the enterprises, the small businesses, the citizens, and the municipalities themselves. So we have the external and the internal services. It's very important to see also the internal services of the municipalities moving forward. Using and reusing existing and well-proven standards and models like ISA 2 vocabularies or the W3C SCOS recommendation is key. And it's key not only to use the smart technologies, but it's the key for enabling the smart city. The main thing a knowledge graph provides to a smart city is a common language to all different stakeholders of the city, and it's providing the interoperability for the heterogeneous knowledge and the heterogeneous services. Last but not least, cities have always been marketplaces that have been based on collaboration and cooperation. Collaboration and cooperation are based on understanding and trust, which is both provided as content and context in the knowledge graph itself. So maybe some thoughts to take away and maybe some thoughts to discuss in the Q&A session.
Thank you very much. So I'll see if I'm able to pick up some questions if we have any. Didn't have any questions. Let's see. How do I open up the floor for the participants if they would like to address the questions? It seems like we had a very crispy and nice narrative, Sebastian and Martin. We haven't gotten any questions so far. So we will leave you with some further reading post this webinar. I think one thing is quite good to look at, because we're talking about AI, artificial intelligence. Artificial intelligence, as mentioned before, is algorithms. Algorithms is what we call routines that we as humans have used to coordinate our efforts. And they have been programmed into our tools. And then the tools have started to learn how to improve those algorithms. It is quite interesting to look at what will the future bring. I recommend to you all to read the very good book Life 3.0 by a fellow researcher, Max, Swedish researcher who just published that last autumn about where we are going in terms of AI and beyond. What are the governing principles? A couple of weeks ago, one of the main players in this arena, Google, published their governing principles on how to use AI and where and why. And because if we are looking into the future and we have basically talked about narrow AI, which is improving different algorithms like natural language processing, machine learning for different specific models, and deep learning networks to reinforcing different principles and so forth. But when we're looking into the future of artificial general intelligence, what principles do we have for that future? Because that future is already showing its face. Even if we might not see it during our lifetime, we have to have the core principles in place. because it could turn bad. So I'll leave you with these kind of thoughts. I think it's good to visit the recent blog post by Google and some others as well, where they actually state quite really good, I would say, principles. It has been in a lively discussion in the AI community lately. Thank you very much, everybody. And do you have anything you would like to add, Martin, before we close down?
Oh, just a very big thank you to the both of you for making this happen, and for the audience to listen to us, and for your interest. And I think we'll send some information to participants and registries. Also, we provide the slides and the recording, I guess, in a couple of days. Thanks a lot to you and to the audience.
Thank you very
Bye-bye.
much.
Bye.